And we're back in Better Than Ever again in 11.3, where we're going to be wrapping up our discussion on reactions and aqueous solutions. In this podcast, we're going to take a look at 3 double replacement reactions, predict the products, and then go back and take a look at the solubility of those products. In this first reaction, we have sulfuric acid, H2SO4, reacting with barium chloride. Now, in a double replacement reaction, the cations are going to swap with one another. So the hydrogen will replace the barium will replace the the hydrogen will replace the barium will replace the hydrogen. Now when you write the formulas, you have to go back to the original charges of these compounds, or of these ions. So for example, when we have barium sulfate forming, barium, this is a 2+ cation. The sulfate ion is SO4 2-. We know this from our list of polyatomic ions. We know this one because it is an alkaline earth metal and they form +2s. The +2 and the -2 combine in a 1-to-1 ratio, and so what you're left with is BaSO4. In the second product, you have hydrogen going with the chloride ion. Well, the hydrogen is a +1 cation. The chloride ion is a -1 cation, so you only need one hydrogen to balance the charge on one chloride. So you simply have HCl. We go back through and we balance the equation. You have 2 hydrogens on the reactant side. You only have 1 on the product side, so we need to put a 2 out front. We have 1 sulfate on the reactant side. We have 1 sulfate on the product side. We have 1 barium, 2 chlorides. 2 times 1 gives us 2 chlorides, and now we are balanced for mass. And in fact, we are also balanced for charge. The last thing that we need to do is double check our solubility of these individual compounds. The barium sulfate. Well, one of the rules is that sulfate salts tend to be soluble. That's right here. However, barium is one of those exceptions. And so we're going to have to go back down and say that this is going to be a solid, not aqueous. That's going to precipitate out. The hydrogen chloride that forms, scrolling up just a little bit, chloride salts are generally soluble. There's no rule for the hydrogen, and so we're going to assume that this thing will be soluble, so we'll put an AQ behind it. And so now we've completed this reaction. We've predicted the products. We have also balanced the equation, and we've also double-checked the solubility rules. Moving on to the next reaction, we have the reaction between aluminum sulfate and ammonium hydroxide. Now we know that the aluminum sulfate is soluble based on the solubility rules because sulfates are soluble and there's no rule for the aluminum. The ammonium hydroxide is soluble not because of the hydroxide, they actually tend to be insoluble, but the ammonium ion, NH4, is soluble, so that's why that particular salt is also soluble. Now, when you do this double replacement, the aluminum and the ammonium will swap. It's the double replacement. The ammonium is a +1. The sulfate is still a -2. Now remember, you don't just simply take one ammonium and the 3 sulfates and stick them together. You are not going to write NH4SO4 3. The subscripts come from the charges of each individual ion. So you have to go back to the original charges. Ammonium is a +1, sulfate is a -2. So you're going to need 2 ammoniums for every sulfate. Now the other way that you can think about this is having the 2 crisscross down from the sulfate to the ammonium, and the 1 from the ammonium going with the sulfate. Of course, you don't put parentheses with the 1 behind it, you just leave it. So you would have NH4 2 SO4. The second product would be between aluminum and hydroxide. The aluminum is a +3, the hydroxide is a -1. So again, you do not write Al2OH and then just carry this entire thing over and this entire thing over. You go back to the original charges. Aluminum is a +3, hydroxide is a -1. Therefore, you need 3 hydroxides to balance the charge on 1 aluminum. Now the other way you can think about this is the crisscross. If there was a 3+ above the aluminum, that would go with the hydroxide. The 1- the 1 from the aluminum would, the 1 from the hydroxide would go with the aluminum. Now we need to balance this equation. We have 2 aluminums on the reactant side. We only have 1 on the product side, so we need to put a 2 out front. We have 3 sulfate ions on the reactant side. We only have 1 on this product side, so we're going to put a 3 out front. We now have 6 ammoniums on the reactant side. We only have 1 on the product side, so we need to put a 6 out front. Remember, 3 times the 2 gives us 6 on the product side, so we need to put that 6 out front. We now have 6 hydroxides on the reactant side. We have 2 times 3 is 6 hydroxides on the product side, so this is balanced. It's a 1 to 6 to 3 to 2 ratio. Now let's finally check our solubility rules. Sulfates tend to be soluble. Scroll up here. Sulfates are soluble. The ammonium is not an exception. In fact, the ammonium has its own rule, and ammonium is also soluble, so that is going to be AQ. With the aluminum hydroxide, the very last rule is that hydroxides are not soluble. They tend to be solid. Aluminum has no rule, so we have to go with the hydroxide rule, so we'll put an S behind that. So this is also a precipitation reaction. The aluminum hydroxide will precipitate out. Alright? Let's go ahead and try the last equation here between silver nitrate and hydrogen sulfide. The double swap, the silver will go with the sulfide, the hydrogen will go with the nitrate ion. Silver is a +1, the sulfide ion is a 2-, so we're going to need 2 silvers for every 1 sulfide. The formula will be Ag2S. The hydrogen is a +1, the nitrate is a -1. The +1 and the -1 will balance in a 1-to-1, so we just simply write HNO3. Double checking your solubility rules. Sulfides are generally not soluble, so we need to put an S behind it. Silver has no rule. In fact, silver tends not to be soluble anyway. And then when you take a look at the hydrogen nitrate, which is actually nitric acid, the nitrate ions are soluble in almost all cases, so we'll put an AQ behind that. Now we simply need to balance the equation. We have 1 silver, we have 2 silvers on the product side, so we put a 2 out front. You have 2 nitrates on the reactant side, you only have 1 on the product side, so we put a 2 out front. You have 2 hydrogens on the product side, go back, we have 2 on the reactant side, and now we're balanced. So, what we've done in this last podcast here is we've predicted products by using a double replacement reaction. We went back to the original charges to predict the formulas on those products. We balanced the equations, and then we checked our solubility rules to determine whether or not the products were going to be aqueous, meaning that they're soluble, or if they're insoluble, solids, so we put the S behind those. Alright? If you have questions, see me. Otherwise, that concludes Chapter 11.